All right, here's objective 2 about hyperbolas, being able to write the equation now. So we're going to start talking about the equations of some hyperbolas, and you will see that it's very, very similar to the ones for the ellipses with one key difference. So in the picture that you see here, this is one of those things that's called a long exposure, where they leave the camera aperture open and all the light that is in the area just keeps exposing and exposing. Well, traditionally it would have been a film negative, but now they, of course, do it digitally. So anyway, what you're seeing here in the background, that is a church in Brazil, the capital Brazil. I believe it's called Corpus Christi. You can see that the shape of it is hyperbola. It's very cool architecture. And the things that look like waves, I believe that those are just, say, torches that people are running across the field of the camera. So it makes for a pretty interesting picture. So we looked at the points for all of the hyperbolas with either the transverse, the horizontal transverse axis, or the vertical one. So now let's look at the equations. So for a horizontal transverse axis, let me point something out again to you. With this transverse axis, the A is in transverse, so that gets the 2A. And that's the length of the transverse axis. Now horizontal, if it's horizontal, that's the coordinates, in other words, the x coordinates. That's where the A is going to go. And it's always going to be the positive term. The transverse axis always gets the positive term. So it always gets the positive, like the x term, x squared or the y squared. So that's why the x minus h quantity squared is the one that's coming first over a squared. And then we have a minus right here for the y squared. So the b down there means that I have a vertical conjugate axis. And then again, just like the ellipse, this thing is equal to 1. So the main difference here between these things is that the hyperbola has a minus sign in between them, and the A always went with whichever one was bigger. Here the A is always going to go with the positive term, and that one will determine whether you have a horizontal or a vertical transverse axis. So let's look at the next one with the vertical transverse axis. So again, transverse, it goes with the A value. And look at where the A value is this time. It's in the exact same spot, but on top, it's the y value that's coming first in order to keep it positive. So whenever the y squared is the positive term, this means we're going to have a vertical transverse axis. Remember that the A for hyperbola is not necessarily bigger than B. So it's not the bigger number like we're used to seeing with the ellipses. It's the one with the positive square term. So this one, y squared. Okay. So here's a couple of pro tips about this, and that's this one uses the regular Pythagorean theorem. So here's a couple of ways to help you remember that. So first of all, you just think of a picture of hyperbola with you having half of the transverse axis and half of the conjugate axis, and then the length of the hypotenuse is c, which is half of the focal length. I'm about to have a coughing fit. Of course. Why not? Okay, this one's even easier, and this one relates to what we did with the ellipse. If I take a look at the equation of the hyperbola, it has a minus sign in between the x squared and the y squared. And if I look at the equation that relates the A, the B, and the C, the Pythagorean theorem, it has a plus sign. It's opposite. And if you look back at your flow chart, or if you think back to the one for the ellipse, those two signs just get switched. So the signs are always opposite. If you have a minus sign in your equation when it's in standard form, then you have a plus sign in the c squared equals a squared plus b squared, and vice versa. Okay? It's always opposite. Here's the next one. And this is just kind of a summary of things that I've pretty much said quite a few times. The length of the transverse axis is 2a, and I have an a right there in the transverse axis. I know some of you probably in the comments are going to say, well, there's an a in the conjugate axis too. Just totally ignore that a. That one doesn't count. Anyway, Also, the a value is not necessarily bigger than the b value. The a value always goes with the positive square term. So here's something else that's pretty easy to remember. Look at the difference between the t and the c. The t looks kind of like a plus sign, right? Which is the positive. So putting those things together, the a goes with the positive term, which is on the transverse axis. And you can see that play out right down below, not on the next slide, on this one. A squared, it's going with the x squared term, which means that it must be a transverse axis, horizontal transverse axis. And the a squared on the second one is underneath the y squared, so this one's going to be a vertical transverse axis. Oh, let's actually do some math here, right, guys? Find the standard equation of the hyperbola. I've got two foci, negative 1, 2, 5, 2, and its vertices are at 0, 2, and 4, 2. And remember, these things are on the same line. What line are they on? The transverse axis. And just take a look at this. My 2's are all the same. All my y coordinates are the same. The only thing that's changing are my x values. When I'm changing my x values, I know I'm going like this. My y values are staying at 2, but my x values are changing. It's going left and right, so this must be a horizontal transverse axis. And of course, you could draw yourself a picture if you need to for this. So what I need is I need an A, I need a B, and I need my center point, right? If I look back here, I need my center point, and I need an A value and a B value. And since I found that the horizontal, the transverse axis is horizontal, that means it's going to go with the x squared term, and that one's going to go first. So let's find the lengths of these things. First of all, center point. Center point is at the average between the vertices or the average of the foci. I'll give you the same number. So 0 plus 4 over 2, and the y coordinates are staying the same. So this is 2, 2. Why is that underlined? I don't know. 2, 2. So there's the center point. And I need an A value and a B value. So the A value I can just simply get from these two vertices. Just subtract the two x coordinates. So 2a is going to be equal to 4 minus 0, which is just 4. Divide it, and so a is equal to 2. I got my A value. From my foci, I should be able to get my C value. So for my C value, 2c is equal to, do the same thing, subtract the x coordinates. So here 5 minus a negative, so plus 1 is 6, so c is equal to 3. And now put them together in the regular Pythagorean theorem in order to find the b value. So c squared is equal to a squared plus b squared. So c squared, that's going to be 9, equals a squared to 4 is equal to b squared. Subtract over the 4, that's going to give me b squared is equal to 5, so b is equal to the square root of 5. Now I can put all of this stuff together and write the equation in standard form. Which one was going to come first? Which one is the positive one? Since this is a horizontal transverse axis, it's got to be the x. X minus 2 squared from the center point, divided by, I need my a squared. A was 2, so that's going to be divided by 4, minus, now do the same thing for the y coordinates, y minus 2, again from the center point, squared, divided by, this is the b value, so it's the square root of 5 squared, which is 5, is equal to 1. And there's my equation. That was fun.